In this tutorial, we classify triangles by the sides that make up the triangle using the Desmos geometry tools. A triangle includes three angles whose sum is 180 degrees. A triangle includes three sides of specific lengths. This brings up three scenarios. The first scenario is when all three sides are of different lengths. A scalene triangle consists of three sides of different lengths. Triangle ABC has side lengths of 4, 5, and 6. It is an example of a scalene triangle. The second scenario is when two of the sides are congruent. An isosceles triangle has two sides that are congruent. Triangle ABC has two sides of length 5 and one side of length 3. It is an example of an isosceles triangle. The third scenario is when all three sides are congruent. An equilateral triangle has all three sides congruent. Triangle ABC has all three sides of length 6. It is an example of an equilateral triangle. In a previous video, you saw the three types of triangles classified by angle. This table looks at combinations of these classifications. Along the top are classifications by side. Along the side are the classifications by angle. Where a row and column intersect is a triangle that has both characteristics. Not all combinations are possible. This table shows which types of triangles are permitted and which aren't. Let's look at each type of example. Let's start by looking at different types of scalene triangles. This is an example of a scalene acute triangle. See how each angle is less than 90 degrees? See how none of the side lengths are congruent? This is an example of a scalene obtuse triangle. See the obtuse angle? See how none of the side lengths are congruent? This is an example of a scalene right triangle. See the right angle? See how none of the side lengths are congruent? Now let's look at different types of isosceles triangles. This is an example of an isosceles acute triangle. See the two congruent sides? See the congruent base angles? See how all three angles are acute? This is an example of an isosceles obtuse triangle. See the two congruent sides? See the congruent base angles? See the obtuse angle? This is an example of an isosceles right triangle. See the two congruent sides? See the congruent base angles? See the right angle? Now let's look at the single case of equilateral triangles. This is an example of an equilateral triangle. See the three congruent sides? See the three congruent angles? All angles are acute. Notice that it is also an equiangular triangle. Now the reasons that there can't be an equilateral obtuse or right triangle are twofold. First, while it's possible to create an obtuse or right angle, in each case the sides would no longer be congruent. Also, changing any of the angles would no longer make all three angles congruent. For these reasons, equilateral triangles are acute only. This is why this summary table has X's for equilateral obtuse and equilateral right. Let's use the Desmos geometry tools to construct these different types of triangles. Click on the polygon tool. Click once and move to a different point on the screen. Click again. Move to a third point. Click again. Finally, click on the original point. You should see a triangle. Label the triangle. And measure the side lengths. Try to get your triangle to look like this. Create a scalene triangle. Click on any of the points and move it to create the triangle. Here is an example of a scalene triangle. Next, manipulate C to create an isosceles triangle. Try to get the congruent side lengths to be whole numbers. This is an example of an isosceles triangle. Next, create an equilateral triangle. This one may be a challenge. You'll need to move all 3 points to get 3 congruent sides. This is an example of an equilateral triangle. Measure the angles of the triangle. Can you see that the equilateral triangle is also an equiangular triangle? Manipulate the points to create a scalene acute triangle. This is an example of such a triangle. See the 3 different side lengths? See the acute angles? Now create a scalene obtuse triangle, like the one shown here. See the 3 sides that are different lengths? See the obtuse angle? Next, create a scalene right triangle, like the one shown here. See the 3 sides that are different lengths? See the right angle? Next, create an isosceles acute triangle, like the one shown here. See the 2 congruent sides? See the congruent base angles? See the acute angles? Next, create an isosceles obtuse triangle, like the one shown here. See the 2 congruent sides? See the congruent base angles? See the obtuse angle? Finally, create an isosceles right triangle, like the one shown here. See the 2 congruent sides? See the congruent base angles? See the right angle?